Okay, here we're going to see Seaborn. Import the usual stuff, plus Seaborn. Remember that the alias SNS is the one we're going to use for Seaborn. Plotting and Visualization 3, Chapter 903. Seaborn is a Python data visualization library based on Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. Matplotlib is mainly deployed for basic plotting. Visualization using Matplotlib generally consists of bars, pies, lines, scatter plots, and so on. Seaborn, on the other hand, provides a variety of visualization patterns. It uses fewer syntax and has interesting default themes. Seaborn provides an API on top of Matplotlib. This makes the drawing a little bit slower, but prettier. These are a few links for you. Example A. Let's see, we're going to print a built-in dataset file called Iris. We want to see a list. We're going to see a list with this line here of the available datasets that Seaborn brings built in. Then we're gonna set the style to dark grid, which is one that I like. And in Seaborn, you do it like this. Okay, this one's called a strip plot. X is going to be the iris's species. Y is going to be the petal length. The data is iris, and the line width is 0 right now. We're going to see what that means in a moment. Okay, so here we have the list of test data data sets that Seaborn has. We're using Iris, and later on we're going to use penguins. Here we see the strip plot of scatter dots. It gives a nice, the dark grid gives us the background there. And we have the petal length. Moving on. Okay, example B. We're going to be dealing with how many people are in a restaurant scenario, how many people in this particular waitress in a few days of the week. So we read, this is from the book, Tips CSV. A cross tab will give us a two-dimensional cross tabulation between the days and the size of the party. And we call that, it's a pandas data frame called party counts. You're going to see that there are not too many parties in that restaurant with 1 or 6 persons. And so we're going to ignore those. So this function here allows us to ignore all of those except the second column and the fifth column. I mean, these are not the column numbers. This is not a usual slice. This is lock. This is the name of the column. So we're going to ignore everything except column for 2 through 5. So we're ignoring column 1, which is one person alone dining, or 6 people dining, because apparently they have very little data when compared to the rest. If you see the second data frame here, we've ignored 1 and 6 size parties, and that's this plot here. So apparently the majority of the parties are of 2 people, and the minority of the parties is 5 people. And we have that on Friday there were no 5 people parties. That graph was normalized. This is an interesting line here that I suggest you study further. It's a division that allows the data, that makes the data go from 0 to 1 to show it in a percentage kind of mode. You see here, all the data was flattened out to fit between 0 and 1 proportionally. So you can say that these are percentages. Moving on. Example C. Now we're going to be dealing with the tips that that particular waiter or waitress gets. We read the CSV into the tips data frame, and I sorted it. I added this line here to sort it to see actually with sorting it by time, and then which is the morning or afternoon or evening, and the day of the week inside every one of those, to see about the Thursdays. We have a little situation where apparently there's no data for a couple of times there. I noticed that the book uses this equation to display percentages, but I don't know, I'm using this one here, which is really a percentage for the tips, like 20% tip, 15% tip, and so on. It is a bar plot with the percentage on the X. Y is going to be the day. Hue gives us a color differentiation between the Y's, and the data comes from, since we're using Seaborn, this is the syntax to execute the bar plot. We need to include an argument there mentioning the data frame, and the orientation for that bar plot is horizontal. We have sorted in place by the tip percentage in descending order, and I found out what this function does. Head for a data frame, by default, without an argument there, prints the first 5 rows of your data frame. I'm printing 10. So this is what we get. If you notice, the data frame has the total bill, the tip given, whether it's a smoker or not. I sorted it by day of the week. And yes, it's true that for Thursdays we seem to have lunch only. See, there are no dinners for Thursday. Friday has lunch and only also. Sunday has dinner. Only. So, if you notice on the graph, Sundays and Saturdays were only dinner and have only dinner in the table, and Fridays and Thursdays have both. The percentage of the tip, you see that it approaches 20% here on Friday lunch. Here I've printed down here, after sorting it by tip percentage, you see that there's one day here, 71%. It's a $7 bill and they got $5 and so forth, but I'm only showing 10. I'm wondering about that percentage because it's not showing this one. I'm going to revert to the one in the book to see what's going on there. So I'm going to use the percentage calculation in the book and comment my percentage equation. Still, there's something funky there. I don't know. Oh, because the data is it an average? I don't know. At any rate, let's move on. Okay, for this one, I'm going to run it because it takes so long. We're going to do histograms and density plots. We read the tips database into a data frame, a pandas data frame. We set the style as a white grid for the Seaborn style. We use my percentage calculation rather than the book one. And we plot a histogram from our data frame. That's the syntax in Seaborn for a histogram with 50 bins. So we have the percentage at the X and the histogram. Oh, because it's frequencies. How many of that type of? Oh, here we're showing the 70% tip there and so forth. All right, everything's good. Now we're going to see a Seaborn plot, density plot. Right on, I love these ones. Here we have the little blip of the 70% tip. Looks like we have at least one 40%. Most of them are a little bit less than the 20% that you should be giving. All right, Seaborn. Seaborn is cool. Now we're gonna see example B, histograms and density plots. Part 2, this is the pro stuff. An early step in any effort to analyze or model data should be to understand how the variables are distributed. Techniques for distribution visualization can provide quick answers to many important questions. What range do the observations cover? What is their central tendency? Are they heavily skewed in one direction? Is there evidence of bimodality, perhaps? Bimodality is when you see two bumps or in a graph. There could be three bumps or multiple multimodalities. Are there significant outliers, like we saw that 7% tip? Do the answers to these questions vary across subsets within the data or defined by other variables? We're going to use the penguins data set built in from Seaborn. We load it into the penguins the variable. It might be a data frame. We use Seaborn to display a plot of penguins where the x is going to be the flipper length in millimeters. All right, so it looks like the majority of the penguins have about 190 something millimeter length fins, flippers. And we have a bimodal one. You see there are two bumps. All right. Now we're going to see variation where we're going to use the argument called hues, which will give us a different coloring on the bars. Bars. God, why do I do shh? Gotta stop that. Okay. Hue by the species. Nice. I don't know where that gray one comes from. I would have to look at the data. It may be another species that is not. I don't know. I would love to know. At any rate, you see the different colors by the species. Adelie, chinstrap, and Gentoo. Penguin. Kernel density estimation, KDE. Rather than using discrete bins, a KDE plot smooths the observations with a Gaussian, a Gaussian kernel, producing a continuous density estimate. The first example on that is, here you see the kind is KDE. I think your homework requires one of those, of the flipper length in millimeters. This is bimodal. Now we're going to add an argument to our Seaborn displot function. We're going to use hue by the species. There they are. All right. Now we're going to do hue plus fill is true. Kernel density estimation. Nice. All right. Next example. Okay, example F, scatter or point plots. This is macro data of some social thingy. Put it in the data frame, the pandas data frame. Then we're going to use these columns, and we're going to do a logarithm and so forth. I have no clue what this line does. It's a mathematical thing that you are really good at. I hope that you decipher it and teach me what it is. This one's called a pair plot. It's going to do pairing of all kinds of stuff. My God. It's a KDE. I have no clue. Well, alpha is the transparency. I need to find out what that argument does. Yay! Alright, whatever. You'll decipher it. See, but it's trans data. So it kind of did the same on the Y and the same on the left. You see, CPI, M1, ONM, no, ONM, T bill rate here and here, M1 here and here, CPI here and here. Well, you will decipher it, please. Moving on. Okay, example G, facet grids and categorical data. The Seaborn face grid class maps a dataset onto multiple axes, arrayed in a grid of rows and columns that correspond to levels of variables in the dataset. The plots it produces are often called lattice, trellis, or small multiple graphics. We use the tips database dataset. We use Seaborn facet grid with the data frame. The column is time, which were the afternoon, morning, and so forth. The grid map of a his plot it used the time and it found two of those. It created two subplots with the same x on both. I guess that's percentage. I don't know. You tell me. I just work here. Alright, moving on. I know. The last one. God, this is too much for me. You're the scientist. You're the data scientist here. Teach me. Cat plots and categorical data. Example H. We use the tips file. We're going to use the books percentage calculation. I have no clue why they did it like that. We're going to display the first 10 with the head function and use the factor plot function. In the book it says factor plot, but apparently it has been renamed to cat plot, categories plot. It's Seaborn categories plot. The x is going to be the day. The y is going to be the percentage of the tip. It's going to view it. It's going to give us a view on the time. Only the smokers. It's a bar chart. And I don't know why they did this to control the percentage. Only, I guess, percentage less than 1. Okay. Oh, so here we're having the smokers who gave less than 1%, I suppose. Yeah. And it did it again for smokers and non-smokers. It viewed it by the day. No lunch on Sundays and Saturdays. Percentage-wise, here. You teach me. I love you. Good night. On to the homework.